This is 3.3, transforming linear functions. I'm also going to add just general functions, because once we learn how to transform linear functions, you can transform any function in the same manner. So I want you to consider, let's say if I start off with 2x as the starting function. And if I start graphing y equals 2x, it's going to end up looking like this. And I want you to notice the blue. So the only thing difference with the blue equation is the plus 3. So again, normally we would just graph the blue one and don't even think about it. We just graph it like we would normally do. But I want you to notice it and compare it. Like, what's the difference between the starting function and the new function? So the new function, notice it's being adding to 3. So in other words, it's being raised 3 spots. So literally every point is being raised 3 spots. So raise it 3 spots, raise it 3 spots, raise it 3 spots, raise it 3 spots. And so notice you have the blue line just like that. And if I had another function, let's call it the green line, let's say 2x minus 4. Well, notice it's still 2x, just like the starting function. So the starting function is still there, but the negative 4, or it's being lowered 4 spaces. So if I lower every point of the red, so lower it 4 spaces, lower it 4 spaces, lower it 4 spaces, lower it 4 spaces, and you're going to get each one of those, and you can graph it. And notice all I did is I look at this outside number, and I raise it or I lower it. So that's really all you're going to be doing if you know the starting function. So let's look at an example here. Notice I have the red equation. Notice that it's starting at -1. Let me use red. Starting at -1. And if we graph down 4 over 3, down 4 over 3, if we graph the red one, or up 4. So if we graph the red one, it's going to look like this. And notice the difference between the red and the blue. Notice this one, from -1, it's changing to -6. So notice it's going down 5 spaces. From -1 to -6, it's going down 5 spaces. So if I lower everything 5 spaces, lower this 5 spaces, lower this 5 spaces, so notice I can graph the blue line just by noticing, hey, it's still -4/3 x, still -4/3 x, but it started, this one started at -1, this one's starting at -6, so it's really being dropped 5 spaces. Again, the number on the outside, it's going to be raising it or lowering it. So notice this one, if I had y equals 2x, the red one, and then this one is 6x. Well, notice this one's actually, what's changing, there is no number out here, there is no number out here, so I'm not raising it, I'm not lowering it, but notice I'm multiplying it by a factor of 3. So the red function, if I literally looked at the red function and started graphing that, it would look like this again. And the blue function is literally growing 3 times quicker. So you're like, what do you mean growing? Well, notice this, the red one is rising 2 and running over 1. See, that's the slope. So it's rising 2 over 1, rising 2. So it's going 2, and this one is going to be literally growing 3 times faster. So literally everything is being multiplied by 3, a factor of 3. So if you literally multiply everything by 3, you're going up. So notice here I went up 2, but now I'm actually going to multiply by 3, which means I'm going up 6. Let me change it to blue. All right, so I'm literally multiplying it by 6 to be able to get that. So you're literally going to be doing that on each one of those. And so the first one that's here, and I'm going to, the second point, if I look at the second one, it was raising up. You can keep doing it. So it's rising 2 over 1, rising 2. The red one is going up 2 over 1, up 2 over 1. So the other one is literally being multiplied by 3 to get to your next one to be able to do that. So it's going to be 12, and it's going Again, it's not starting anywhere different, but it's growing 3 times quicker. So if you look at this one, notice the starting function, and we may not be graphing every one of these problems, but I want you to notice the number out. There's no number on the outside, so it's not raising or lowering, but the number, this is a 1, and notice this is 1/8. So this one is, if you want to say it's growing 1/8 less, but it's not, it's kind of like a shrinking factor. So if something is only 1/8 of the size, you know, it's being like divided by 8. It's only growing 1/8 as fast as the other one. So this one right here, the number on in the front, just like the previous problem, that's like the growth factor. So this has a growth factor of 1/8. The other one had a growth factor of 2. So if you look at each one of these, so describe the transformation starting with this function. What's different? So I want you to describe it in words. So notice you have a number on the outside. It's being raised. You still have y equals x, but it's being plus 8. So this one is being raised 8 spaces. So if we graph this equation and graph this equation, the difference is it's being raised 8 spaces. This is right here. Notice I still have y equals x, but this number on the outside raises it or lowers it. So this one lowers it 1 spot, lowers 1 space. And the number out front makes it grow 2 times quicker. So has a growth of times 2. Now, the number on the inside, we haven't mentioned this yet, but if we have a number on the inside of the parenthesis, it actually shifts it to the left or to the right. It's always the opposite direction. So here, because you don't have a number out here, like if I had a number out here, then that would be raising it up or down. The number on the inside is going to take it to the left or to the right, and it's always the opposite direction. So because that's a positive 6, we're actually going to take it 6 spaces to the left. So 6 spaces left. And notice the number on the outside means it's growing 4 times quicker. 4 times. So let's look at this final one here. So the number on the outside raises it 3. The number on the inside is going to take it 5 to the right. Remember, always go to the opposite direction, what's on the inside. And then this is a 1/2 growth factor. So it grows half as fast. Compared to this function. Everything's being compared to that function. So let's look at this one. Now, here I have all the words, and I want you to write the function. So write the function that is shifted down 4 spaces, 3 spaces to the right, growing 3 times faster, and the starting parent function is y equals x. So you're going to start with y equals x, but you're going to do everything that the words tell you to do. So write the function that is shifted down 4 spaces. So remember that we're going to have a parenthesis, we're going to have a number out here, and we're going to have a number out here. All right, so 4 spaces, that it's shifted 4 spaces. This says write the function that is shifted down 4 spaces. That's -4. It's 3 spaces to the right, which is -3. Remember, it's always to the opposite direction. So this would be actually a -3. It's growing 3 times quicker. So notice I have this function right here. And if I graphed this function, and if I graphed this function, you would see that it is shifted down 4 spaces, it's 3 spaces to the right, and it's growing 3 times faster than this parent function. So let's look at some other parent functions. So far we've been looking at this y equals x. That's just a basic line, like a diagonal line, y equals x. Now, so we just got done talking about this one right here, y equals x. That's the basic line that goes right through the center, a diagonal line. Now let's look at some other common functions that you're going to come across. So y equals x squared is a common function. If you graph that, it would look like this. It's called a parabola, and it would look like that. So if you make an xy chart, you know, when you plug 0 in, it's going to be 0. Plug 1 in, it's going to be 1. When I plug 2 in, it's going to be 4. When I plug 3 in, it's going to be 9. I'm just squaring everything. So if you graph that, notice it looks like that. All right, so we graphed it. That's the parent function. If we did the same thing, make an xy chart with an x, the square root of x, 0, the square root of 0 is 0, 1, the square root of 1 is 1, 4, the square root of 4 is 2, 9, the square root of 9 is 3, and then I graph those points. So that's what the square root function looks like. And then the absolute value. Again, if we made an xy chart, put 0 in, the absolute value of 0 is 0. Put 1 in, the absolute value of 1 is 1. Put 2 in, the absolute value of 2 is 2. And the same thing with negatives. If I put negative 1 in, the absolute value of negative 1 is positive 1. Put negative 2 in, the absolute value is 2. It's always, this y column will always be positive. So the graph is going to look like a V. All right, so as long as you know the parent functions, what we're going to do is start shifting it and doing certain things to it. So let's look at our first one. So what if I had x squared plus 4? Well, x squared, remember what x squared looks like. X squared looks like this. That's what x squared looks like. But now, if I wanted you to graph this, x squared plus 4, you're going to literally shift it up 4 spaces. So shift this point up 4 spaces, shift this space up 4, and we're going to literally shift everything up 4 spaces. And so the parabola is going to look like this. It's being shifted up 4 spaces. So let's look at this one. So what if I had y equals x squared minus 3? Well, again, the parabola that is normally here, that's what the normal parabola looks like. Then what we're going to do is shift it down 3 spaces. So we're going to literally shift it down 3 spaces, shift this one down 3 spaces, and everything gets shifted down 3 spaces. And then you're going to draw your parabola. It's the same parabola, it's just shifted down. So let's look at this function. Do a different number than 4, let's do 5. So remember, it's the same parabola. So think of the normal parabola. That's the normal parabola. But I'm going to shift it 5 spaces up and going to shift it 4 to the right. So literally shift everything up 5 spaces up and 4 to the right. So this point shifted there. And that's really what I'm going to do. I'm going to shift everything 5 up and 4 to the right. So 5 up, 4 to the right. And then every single thing gets 5 up, and then 4 to the right. And so that parabola is going to look like that, graphing it. And the same thing with each one of these functions. So if I take y equals, let's think of the absolute value, like x plus 2 minus 3. Well, think of the normal absolute value function. The normal absolute value function looks like this. That's the normal absolute value. But notice what we're doing is we're dropping it or lowering it, lower 3 spaces, and we're taking it to the left 2. So lower each spot. So we're going to lower it 3 spaces and taking it to the left. So I always start with the vertex. So I lowered it 3 spaces and to the left. And then literally it's going to start the diagonal process. Everything is being lowered and dropped. So not the parabola, but the absolute value function is going to look like that. And by the way, if I put a number on the outside, so if I put like 4 out here, then it's going to be growing 4 times quicker. So it would still be a V-looking shape, but it would be a thinner V. It would be more like this instead of a wider V. So if I have a, by the way, if I have a number out here, out front, let's say with the absolute value, if I have a number out here that's, if this number is bigger than 1, then it's growing, like it's growing quicker. If the number out here is a fraction that's less than 1, then it's going to be making it wider. So this is going to make it a thinner graph, and a fraction is going to make it a wider graph. And that's how you transform any type of function as long as you know the basic parent function.